Namaste. Welcome to Junior Tesla. In this episode of Junior Tesla, I am going to tell you what are the three basic rules of mathematics. And to understand those three basic rules of mathematics, let us have a little historical background. We'll start our episode with a story. We all know what a prime number is. 2, 3, 5, 7, 11, 13, 17, 23, 20, 29, all these are prime numbers, right? So prime number is a number which has only two factors, 1 and itself. It is not divisible by any other number. Now, if you want to generate only odd numbers, odd natural numbers, you can have a formula, right? So odd number is equal to 2n plus 1. Now, if you put n equal to 1, 2, 3, etc., you always end up with an odd number. If you put n equal to 1, you will get 2 into 1 plus 1, which is equal to 3. So like that, you will get always one odd number. Similarly, you know what an even number is, right? So if you want to generate only even numbers, you can have a formula. Even number is equal to 2n. And every time you substitute n equal to 1, 2, 3, etc., you always get one even number. Now similarly, can you have a function, can you have a formula which will generate only prime numbers? This was a challenge, this was a very big question for mathematicians about 500 years ago. So there were many mathematicians who were trying to find a formula for generating only prime numbers. And there was a very famous mathematician, French mathematician called Fermat, and he told in 17th century, yes, I have found a formula for generating only prime numbers. And all the mathematicians were so thrilled, they asked, what is the formula? So he told, f is equal to 2 power k plus 1. This is the formula. Now if you put k equal to 1, 2, 3, etc., you always get one prime number. Suppose if you put k equal to 1, you get 2 power 1 plus 1, which is equal to 5. Similarly, if you put k equal to 2, then 2 power 2, that is 2 power 4 plus 1, 2 power 4 is 16, 16 plus 1 is 17. Yes, that is also a prime number. And if you put k equal to 3, you will end up with another prime number, a bigger prime number. So mathematicians, they checked for some initial values. Every time they got a prime number, they were happy. They thought, okay, this is going to be a formula for generating the prime numbers. Every time you put a value for k, you always get one prime number. And this result, that this is the formula for generating prime numbers, this particular result was known to be true for 100 years. Nobody questioned, because Fermat was a very famous mathematician. He cannot make a mistake. That is what everybody thought. So whatever Fermat has told must be 100% correct. But after 100 years, there was another mathematician, a Swiss mathematician, Leonhard Euler. Okay? So in 18th century, he took up this particular formula and he started working on it, and finally he told, this formula gives prime numbers for k equal to 1, 2, 3 and 4, but not 5. When you put k equal to 5, you get one very large number, okay, very large number, but this number is not a prime number but a composite number. And that is how everybody, they got so stunned, because this is a very big number. If you take some initial values like 2, 3, 4, 5, 6, etc., none of those numbers divide this number. So even Fermat thought this must be a prime number, but no, this is not a prime number. So Euler told, if you take a 3-digit number 641, that number actually divides this number. So this is a composite number, not prime. And that is how the theorem or the result that has been built by Fermat for 100 years, it is crushed, okay, it is demolished. And the new truth was established, that is, there is no formula for generating prime numbers, right? Now Euler, again, he was as famous as Fermat, or you can say even more famous than Fermat. He was a very established mathematician, and Euler, he also had given one statement, okay? He told, suppose if I take an equation a power 4 plus b power 4 plus c power 4 equal to d power 4, okay? If I take this particular equation, then there are no positive integers a, b, c, d that satisfy this equation. That is what Euler told. While working on some algebraic problem, he came up with this particular problem, and he told no, there cannot be any positive integers a, b, c, d that will satisfy this particular equation. Now again, mathematicians believed, because he was a very great mathematician, so whatever he told, there cannot be any mistake, it cannot be wrong, because he has produced hundreds of results, correct results, so they thought even this must be true. It was not challenged. But later, after 245 years, almost 2.5 centuries, okay, there was one mathematician in Harvard called Noah Elkis. Now Noah Elkis took the help of supercomputers and found that this particular statement of Euler is not correct. So we can actually find 4 values, 4 positive integers a, b, c, d. I have written the values of a, b, c and d, these 4 numbers. Now if you substitute these big numbers, now each number is some 5-6 digits, okay, definitely you cannot do it using pen and paper, definitely you need the help of computers, okay. So these big numbers, these large numbers, if they are substituted in this particular equation, the equation will be true. That means it is possible to find positive integers which will satisfy the equation a power 4 plus b power 4 plus c power 4 equal to d power 4. Noah Elkis not only found these 4 values, this person also proved that there can be infinitely many such solutions. So this is not the only solution, there can be n number of solutions. So some mathematicians, they establish some statement and it will be questioned later and a new truth will be established. Now whenever a mathematician comes up with some statement which has not been proved or disproved is called conjecture. Okay, so conjecture is a statement that has not been proved or disproved. Now once the statement called conjecture has been proved, it becomes a theorem, and if it is disproved, then it will not remain as a conjecture, it becomes a false statement. Now to disprove a conjecture, what you have to do is either you have to disprove it using some proof, okay, lengthy proof, or even one small counter example is enough. So in Euler's case, he gave one very small counter example. He told if you put k equal to 5, this will not remain as a prime number. So that is called as counter example. Counter example is one example that disproves an established statement, that disproves a conjecture. Similarly, this is one counter example which disproved Euler's statement. So conjectures are the statements that are not proved or disproved, and counter example is one example that disproves an established statement or a conjecture. Okay, now let us come back to the 3 basic rules of mathematics. The 3 basic rules of mathematics. The first rule, do not accept anything without proof. Do not accept anything without proof, because just because Fermat had told, just because Euler told, you need not accept it unless it is proved. It need not be taken seriously, it need not be taken as truth. So do not accept anything without proof. And rule number 2 is, do not accept anything without proof. And rule number 3, do not accept anything without proof. So in mathematics, if something does not have a proof, it need not be accepted, and once it is proved, it can be considered as the truth. Thank you. For more videos on maths learning, please subscribe our YouTube channel Tesla Education. Also, let us know in the comment section about the topics you would like to learn so that we bring more videos to you. Thank you.